Now, sometimes we can make a design that has an association class, and it turns out we didn't really need it. And we're going to come back to multiplicities to see how this can happen. So again, let's take a look at just generic classes C1 and C2. Let's say that we have an association between them, and then we have an association class. We'll just call it AC. And that's going to have some attributes. We can call them A1 and A2 for now. And of course, there's attributes in C1 and C2 as well. Let's suppose that the multiplicity on, let's say, the left side is star, so anything goes, and on the right side we have 1 to 1. So what that multiplicity says is that each object of C1 is related to at most one object of C2. So, or actually exactly one object in this case. So we know that there's going to be just one association for each object of C1. And if there's only going to be one association, actually we could take these attributes and we could put those attributes as part of C1 instead of having a separate association class. So for example, if this class happened to be the student class and this was the college class, and we insisted that each student applied to exactly one college, then the attributes we had down here, the date and decision, could be moved into the student class because we know they're only applying to one college, so that would be the date and decision for the one college they're applying to. Furthermore, if we had 0.1, we can still move these attributes here. And in that case, if a student was not involved in a college, had not applied to a college at all, or more generally an object of C1 was not related to any object of C2, then those attributes would have the equivalent of null values in them. By the way, it is possible for an association to be between a class and itself. For example, we could have our student class, and maybe we're going to have an association called sibling, a student being associated with another student because they're siblings. An association between a class and itself is written with a line that just goes between the class and itself, and then we could label that sibling. And for multiplicities, we can assume that every student has between 0 and an arbitrary number of siblings, let's say, so we could put a star on both ends of that association. A more interesting association might involve colleges where, say, we have for every college a flagship main campus, but then some colleges have separate branch or satellite campuses. So that would be a an association, between a college and itself, saying that one college is a branch of another college. Now let's think about the multiplicities here. First of all, when we have a self-association, in UML we're allowed to label the two ends of the association. So I could, for example, say on one end we have the home campus, and on another end we have the satellite campus. And now with those labels we can see the asymmetry, and that lets us get our associations right. So let's say that every satellite campus must have exactly one home campus, so that would be a 1.1 here. And every home campus can have any number of satellite campuses. Or actually, let's say something else. Let's say every home campus can have between 0 and 10 satellite campuses. So that would be a 0.10 on that side of the self-association. Okay, we're finished with the first three. Let's move on to subclasses. For subclasses, we're going to do a fairly large example that involves students that we're going to separate into foreign students and domestic students. We're also going to separately specify students who have taken AP classes, and those will be our AP students. So we're going to have the student class as the top of our hierarchy, and the student class will again have the student ID, let's say the student name and GPA, and we'll say that the student ID is the primary key for objects in that class. We're going to have three subclasses. One is going to be the foreign students. We'll call it foreign S. One is going to be the domestic students. And then we're also going to have a subclass for AP students. And I'm going to assume that you already know a little bit about subclassing from programming. So the idea is that when we have a subclass, there are attributes that are specific to the objects that are in that subclass, and they'll inherit the attributes from their superclass. So we're going to make student be a superclass here, and this is how we draw it, with three subclasses here for foreign student, domestic student, and AP students. And we'll say that foreign students have, in addition to a student ID, a student name, and GPA, a country that they come from. We'll say that domestic students are going to have a state that they come from, and we'll also say that they have a social security number, which we don't know that foreign students would necessarily have. AP students, interestingly, is going to be empty. It's not going to have any additional attributes, but the AP students are the students that are going to be allowed to have a relationship with AP courses. We'll say that the AP course has a course number, and that's probably the primary key, and maybe a title for the course and some units for the course. And then when one of our AP students takes the course, we'll call this association took, we're going to have an association class that goes along with that that's going to have the information, let's call it AP info, about them taking that particular AP class, and we'll say that that association class has, for example, the year that they took the class and maybe the grade that they got in the class. And lastly, let's add some multiplicities. Let's say that AP students can take between 1 and 10 AP classes, but they have to have taken at least one to be an AP student. And let's say that every course is taken by at least one student and an arbitrary number of students. So this is one of the biggest UML diagrams we've seen so far. Again, this is a superclass up here, and we have our subclasses down here. And then we also have an association and an association class and some multiplicities. And again, notice that it's okay that there are no attributes in the AP student subclass. That subclass is defined as those students who have taken AP courses. Here's some terminology and properties associated with subclass relationships. Superclasses in UML are sometimes called generalization, with subclasses called specialization. A subclass relationship is said to be complete if every object in the superclass is in at least one subclass, and it's incomplete if that's not the case, and incomplete is also sometimes known as partial. A subclass relationship is known as disjoint if every object is in at most one subclass. In other words, we don't have any objects that are in more than one subclass, and that's sometimes called exclusive. And if it's not disjoint, then it's overlapping, meaning that objects can be in multiple subclasses. We can have any combination of these pairs. So we can have incomplete overlapping or incomplete disjoint, a complete disjoint, or complete overlapping. Let's take a look back at our example. For this example, we will probably have the case that it's a complete subclass relationship. In other words, every student is in at least one subclass. Presumably every student is either a foreign student or a domestic student. And furthermore, we're going to say that it's overlapping because we will have students who, for example, are both a domestic student and an AP student. And in UML, the actual notation is to put little curly braces here to specify that that subclass relationship is complete and overlapping. To illustrate some of the other cases, let's suppose that we didn't have this whole section here with the AP students. We only had foreign and domestic students. In that case, we would say that the subclass relationship is complete, but in that case, it would not be overlapping. It would be disjoint. Or suppose we didn't have this whole left side here, so all we had was the AP student subclass. In that case, it would probably be an incomplete subclass relationship because not everybody is an AP student, and there wouldn't make any difference between overlapping and disjoint since there would only be one subclass in that case.